Okay, hi everybody. My name is Jerry Hovdestad from Behlman, and I'm here to talk about power. You've been hearing, from various presentations about, where we think we're going, and I'm going to go through VITA 62 a little bit, where it's going, and how we're going to try and accomplish some of the things that people want to see. So, a little bit, we're talking about power in the past, present, and future. The future is now. Okay. In the past, as you've heard, everybody was using VME, and people are still trying to predict when VME is going away. Behlman, like everybody else, did a lot of VME power supplies. None of them looked alike. It's just examples of maybe 4 supplies. The one on the upper left, it was actually meant to be fit into a chassis like a card. It had a cover that extended over it, fit into a standard card guides, and the customer had to go through all sorts of contortions to plug it in, to float the connector, big mechanical design, lots of different problems. Other ones there's a redundant supplies, there's a high power supply, there's another redundant supply on the bottom. Everything was different, everything was a big mechanical design, and so, then we decided VPX came around and tried to standardize this, and it has been a really big help. Here's some examples. If you Google some of the early VPX things, they weren't really VPX, but people came out with different things. Here's something that was sort of a VPX format, but has sort of a positronics connector on it, like some of the VME plug-in units that were around. There were units of their own, different air-cooled units with their own form factors, maybe 2-inch pitch. But before the standard was approved, people came out with a lot of different preliminary versions. And once the standard was approved, they came out with a 3U standard and a 6U standard. The 3U standard, the goal was 500 watts. The 6U standard was 1,000 watts, and there's lots of companies, I'd say at least 10 companies now that have supplies that pretty much comply with the original VITA spec. It came out in the, probably about 8 years ago when we revised it in 2016. And right now, Behlman has maybe 20 different models of these two, because the VITA spec does define the form factor, the pinouts, but it doesn't define anything like you could have a 200 watt unit, you could have a 500 watt unit, you could have a 1,000 watt unit. It doesn't define power level, it doesn't tell you how much 5, how much 12, and of course every system requirement is different. But it's still a tremendous advantage to have a form factor and not have to do the mechanical design every single time. So, the reason we have 20 different models is because it's very easy, it doesn't take so much engineering, some minor adjustments, and we can do a lot of different things. So, the future, and the future is now, power on the 3U, where we were talking about goals of 500 watts, power is approaching 1,000 watts. Right now, there's a number of people offering 700 to 800 watts on the 3U, and in the order of approaching 1,200, 1,300 watts on the 6U. There's limits on the cards right now. The 1,000 watts on a 3U does present lots of problems for the chassis people because they have to cool it. And there's limitations, and on the 3U, the limitations really are the input current. You have enough output pins to get you up to about 1,000 watts, but if you only have 40 amp pins on the input, you might be able to push them to 50 under certain conditions. And if you are concerned with low line, let's say you're 28 volts, you want it to operate down to 20 volts, 40 amps is only 800 watts, so you're not going to support 1,000 watts. So, but at 28 volts, on the other hand, you can get, at 40 amps, you can get your, close to the limit, or 50 amps. You can get 1,200 watts or so at nominal line. So You have to be careful about what conditions you're specifying, where you're trying to push it. What you have to do in order to get the higher power is to allow 12-volt centric units. That's things that SOSA wants. And right now, the spec is in the process of being changed to allow the power supply. This SOSA version would have 12 volts and 3.3 aux, and those are the only outputs. You can have other outputs on some of the existing pins if you need it for the backplane. For example, backplanes may still need to have the ability for plus or minus aux or plus or minus 12 volt aux or other voltages, but the spec won't prohibit it, it'll allow that, but a SOSA high power unit would have 12 volts, and that's going to get you up to around 800 watts or so, depending on what you do, maybe a little bit more. And then, of course, you have to look at how to cool it. On the 6U, again, if you can cool it, you can get possibly approaching 1500 watts on the 6U. The output pins will support 120 amps. And that's basically the limit. Even if that's all 12 volts, you're a little bit under 1500 watts. The input, they have double pins on the input, so you can get 80 amps. You can get plenty of input power on the 6U. Again, the problem is how are you going to get the heat out of these high power cards? So there's been a lot of talk, a lot of slides. The upper chart is courtesy of a Prime. I have who's been showing this around in emails and presentations and all, and just basic guidelines. He said there's a little caveat in his charts that basically consult your good thermal engineer if you have high power outputs, but you have potentials of dissipating over 100 watts on the 3U and up to 170 watts maybe on the 6U, and that is a challenge for the chassis people. The things that he talks about on the chart, a regular air-cooled chassis, the calculations here show you can do maybe 50, 60 watts. People are doing more than that on air-cooled chassis, but there are limitations there. There is an approved spec now, VITA 48.8, which is an air flow-through specification. Air blows across the top of the card, so it's cooled through the rails, and it's cooled by the air on top of the card. And people are working to come up with heat sinks that are 48.8 compatible, and there's a lot of discussion about how to incorporate some of these cooling things into the newest specifications if the power is required. 48.8 has some challenges because there's different heat sinks for 3U and 6U, and there's different configurations, so there's multiple types of heat sinks that the specification addresses, and it's different depending on individual system requirements. Beyond that, we have, of course, regular old conduction cool is by far the most common, and you can get close to the power limits with regular old conduction cooled cards. If you're looking at really high power, and there are applications right now looking at high power 6U, you're really talking about VITA 48.4, which is a liquid cooled card where you can run power through, you can run liquid through the cover. Instead of the keyways, you have an inlet and an outlet, and you pump fluid through the cover. And there we're talking about cooling up to 200 watts on the card, and that would easily handle the highest power supply we can envision in this format with the existing mechanical structure. Okay, the next topic of where we're going is system management. Right now, there's a VITA 4611, which has a data format, IPMI format. It's an I2C data structure. But there's a bunch of people offering it, but everybody's doing it different. No one has the same language. You have things are defined as sensors. Some people might call sensor 1 12 volts. Some people might call it input current. There's no standard structure. There's a bunch of proposals on standardizing the power supply data in accordance with 4611, but it's really not up to us. It's really, we need input from the users as to what they'd like to see. And the 4611 people have always said, yes, they need to further address power supply interface, but that still is something that's undergoing. the SOSA software group, system management group was one of the topics being discussed. I'd like to see what they're coming up with and then get it incorporated probably into VITA 62. There's been also discussions about where that definition belongs, and we think, at least my opinion is that it should be in VITA 62 in one standard that can be used and referenced elsewhere. Currently the intelligence in the power supply, talking about intelligent connectors and other things, it can be used for a lot of different things, different purposes. Talked about, you can get tremendous amount of system information by just looking at the power supply. If you can look at, your input power, your input current, input voltage, and your output power, intelligent systems sort of know what to expect, where things should be. If things aren't there, you can take action. You might know it might be an indication of a failure. It might be an indication of maybe you need more cooling. Maybe you can turn up the fans in the chassis or pump more liquid through something. So the intelligent power supply is very important. People are just starting to take advantage of it and starting to program their systems to use the information that's available, and they are looking to standardize that information. I'm sure there's going to be a tremendous amount of effort put in developing these programs, and if every power supply is a completely different structure, it's going to be a big problem in interchangeability. So we do really need to look at coming up with a standard structure for system information. So the updates, right now we're in the process of updating VITA 62. I'll be talking about that tomorrow. I got a time slot where we put out something to, we have a working group now working on updates. Some of the things we're doing is adding a 12-volt centric configuration. For the 6U, there's always been a 12-volt centric. SOSA, very usable. There's a 6U version allowed in VITA 62, and it's been there since the beginning, where it allows all of the output pins to be 12 volts, and the only other voltage is a 3.3 aux, exactly like we want for standard applications like for SOSA. However, for whatever reason, it was done for the 6U and it was ignored for the 3U. There were companies who were pushing for it, but people at the time, 8 years ago or whatever, when they were talking about it, didn't want to do that. So it's not allowed in the 6U. So one of the things we're looking at is to update the 3U specification to allow a 12-volt centric configuration. It won't prohibit using, I don't believe it's going to prohibit having other voltages, but it will allow the major power pins to be 12 volt only. We need to revise the keying. There's certain, and with many different models coming out, we need to really look at the keying, make sure all the different configurations that people are coming out with are covered. We need to define the system management capability and commands, as I talked about before. There are a bunch of other electrical and mechanical updates that need to be done. They're basically sort of clerical, some dimensional things, some and some editorial comments, and those will be incorporated at the same time. Okay, and because VPX it's been a tremendous benefit to Behlman, that we were able to have all these different models. It's a nice growing product. It's really nice. I mean, if you looked at the VME things in the past, you couldn't sell any one system to any other system because people just took the power supply and designed it into some corner of the box that it would fit. Some are L-shaped, some are round, they fit in a missile or whatever. But with VPX, I'm sure we have our cards on 50 different programs, and And it's basically the same card. Sometimes a little bit minor modifications, a little more current here, a little more current there. I could never have done that in the past. I mean, I could maybe come out with 2 models a year, 3 models a year of detailed design. But with the advent of VPX, it allows us to be able to supply the product to a lot of different applications, and it is a money saving as far as development. If you, in the past, I do a power supply, you'd make me do shock and vibration, temperature, humidity, EMI. Well, that's all been done on the card. It's been done once, and the data is available. So there's been tremendous savings already on all of these systems, and I'm sure that's the reason for the joint memo there. They're already seeing some benefits and are looking forward to significant benefits in the future. And because of the so far success of the VITA 62, and there's been other standardizations efforts on power supplies in the past that haven't been anywhere near as successful, we have other specifications coming out, adjunct specifications like 62.1, because we never made provision for 3-phase AC input on 3U, and there's a lot of aircraft applications that need 3-phase input or 270 volt DC input. So VITA 62.1 addresses 3-phase AC inputs. VITA 62, that's in progress. We have working groups going, and we're pretty much through a lot of the 62.1. 62.2 is a connector specification. TE is doing work for 270 volt DC inputs with their standard connector, doing a lot of testing to determine where it can be used at what altitude and what environment. And I think they're somewhat through a lot of the testing, and there's certainly a preliminary version of their 62.2 spec out. And for rugged environments, there's an approved VITA 86 for nasty environments, salt spray. It's a sealed connector, and that specification is approved, and it really basically keeps all of the environment off of the connector. It's still pin compatible with the standard 62 connector, but it's in a sealed, gasketed shell, and they've spent a considerable amount of time, Glen Air, going through the qualification testing and approval process.